Squidbox is a low-cost Bluetooth MIDI controller designed for teaching scales and chords. Compared to other MIDI controllers with many keys, Squidbox only has 8, keeping everything to the same diatonic scale. In this video, we'll start things off with a little demo of how Squidbox works, then we'll shift gears and talk about the development process along with some of the code it's running, and finally we'll end things off with a few clips of what Squidbox can do. Alright, so to give a quick demonstration of how the Squidbox works, I've got the device right here. I'm going to go ahead and turn it on. And then the first thing we see is this main menu. I'll go ahead and jump into the chord scene. And the first thing you'll notice is that we have the keyboard here, but we're not hearing anything. And the reason why is because there's no speakers on the device itself. It's a Bluetooth MIDI device, so in order to play music, we have to connect it up to something else. So I'm going to use this phone here, and then pair the device, and then switch over to something like GarageBand, and then this just has the default piano sound loaded. So now, when we press our keys, we can hear it sending to the phone, and then the phone plays the sound. So each of these 8 keys maps to the 8 diatonic chords in the scale with C, D minor, E minor, F, G, A minor, B diminished, and then back up to C. Using the knob here, we can change the root note to get different sounds. So here is C sharp major. We can also even change the scale that we're in. So instead of major, we can play minor. And we can even get funny with some different modes like Dorian, Phrygian, Lydian. Let's do harmonic minor. And then instead of this triads, I can change it to different chord types. So instead of triads, we can go with 7th chords. Doesn't sound so good in harmonic minor, so let me change that to this one. And already, just with playing with basic menu options, you can get some pretty neat sounds out of it. Let's do 6 notes on Mixolydian in G. Why not? Perfect. If we head out of here, back to the main menu, we also have a single note mode here, so you can just play one note at a time if that floats your boat. We can also do drums here, and in order for drums to play, it's just sending the MIDI notes for a certain octave, but for most drum kits on a DAW, this will map to the standard drums that you'd have in a drum kit. So in GarageBand here, I'll just move over to drums. And then from the Squidbox, you can actually play the drum kit as if it were the notes mapped to those drum notes. Last thing we've got here is just the quit to put the device in sleep mode to save off battery. You can power it up again from right here. Squidbox didn't always start out with the nice sleek form factor that it has right now. It actually spent most of its life in this stage on the breadboard here. With this configuration, we were able to test out all the buttons, the joystick, and the knob for main functionality. Now is also a good time to mention that Squidbox is part of continued development from previous school projects, but a large part of what our group wanted to do this term was to overhaul a lot of things and start from the ground up to create something more robust. This meant doing a lot of code overhauling, but also getting the Squidbox to a more permanent form factor. So once we had everything laid out on the breadboard like we liked, we then started moving to more permanent ways of getting it mounted. So we looked at cutting out some pieces in acrylic or also 3D printing front plates. But eventually we went down the route of creating our own PCB for Squidbox and printed some of these 3D printed back plates for it to hold the battery in place. We even printed this really cool one in orange thermal filament that leaves kind of trace marks of your hands when you hold it and play with it for a while. The last thing I want to cover is just a high-level overview of some of the code. All of it is written in C++ using Platform IO. There's also a GitHub repo in the description where you can find the full source code. I won't get too into the weeds of the nitty-gritty details because a lot of the heavy lifting is done from external libraries, like code for the joystick, knob, screen, and Bluetooth capabilities were all taken from the platform I/O registry and adapted to fit our needs. What I do want to talk about are some of the main classes that provide the Squidbox with functionality, starting with the most important class, which is the Squidbox class. The Squidbox class holds references to all the other components, including the screen, joystick, knob, and buttons, as well as an array of scenes. Now, every scene is a class that represents a discrete state of the Squidbox device. Every single scene encapsulates a unique aspect of the Squidbox operation, which allows for modular design, and each scene can offer a different user experience. For example, we have the main scene where the user can select other scenes to go to. We have the chord scene where the user can play chords, the single note scene where they can just play single notes, and then the drum scene where they can just play drum notes. Every scene also has a menu class, which is a key component of the user interface. It provides a structured and interactive way for the user to navigate through different functionalities within a scene. The menu scene does this by holding on to a collection of menu item objects, where each menu item represents a selectable option or action. Each menu item class contains a few callback functions that can be bound to when the OK button is pressed or when the knob is turned left or right. For example, pressing the OK button might change the scene or turn the device off, but changing the knob might change the root note, the scale, or the chord type. Lastly, I'll leave off with just a couple clips of me playing around with the Squidbox and messing around and making some music. Enjoy.